right, let's jump in and we're going to talk through the elements now. As you're turning off your cameras and muting yourself, we're going to talk through this. So this we see as an example of maybe just a computational spreadsheet for where we are. We've got developing the background data costs what, $13,140. And actually, let me ping somebody else. Aaron, are you there that we could kind of hear you on your phone? Let me see. Okay. Do you have the spreadsheet in front of you?
Slide. Pull it up in my booklet.
I can barely hear you.
I have it open on the screen.
Perfect. That's why I was thinking if we have it open on the screen, you can see it. So can you see developing the background data where it's going to cost $13,140?
Yeah.
Okay. So how many months does it take to get this task done? How many months does it take to complete that task?
6.
6 months from January to June. And therefore, what we did was we just kind of divided 13,140 by 6. So we got that number, $2,190 in terms of a unit cost per month. Does that make sense? The way we just spread out that $13,140 over 6 months?
Yeah, that makes sense, because then, it could either be an average a little bit more or a little bit less, and then it still works out.
That's the key thing. And when I'm talking to a group of architects or landscape architects as well, Seth, the group tends to be a little bit of an easier going bunch. When they say just what you said, yeah, a little bit more, a little bit less, kind of makes sense. We average out. By the way, it's simple, right? We just divide 13,140 by 6. We get 2,190, not a big deal. It's a nice flat line. Talking to a room full of engineers, oh, they begin to shake and kind of quiver a little bit because they're going, oh, Bill, what happens if it's maybe front end loaded and we spend a lot of effort at the beginning and then that kind of tapers off throughout the course of the task? Or maybe it could be back end loaded and it's going to start a little slow and then it's going to really ramp up over the duration of that task. Or I had somebody say, oh, we could make a cute bell-shaped curve where it kind of starts slow and it ramps up to a lot of effort and then it tapers off. Well, again, Aaron, is it a good idea just to divide it by 6 and spread it out?
I think from a realistic standpoint, yeah, because you might spend an entire week on something one month and then only spend a couple of hours the next or something. So I think that makes sense, because it's hard to pinpoint where exactly you're going to spend that time.
To me, it's hard to pinpoint. And in terms of time, time is a precious resource to us, is maybe the most valuable thing in this world. Why would you want to spend all your time trying to plan this curve out, this up and down, and when we're going to do this task and that task, rather than just divide it by 6, spread it out, and we say, hey, in January, if there's, how many things happen in January? 1, 2, 3, 4, 5, 6 things, right? If those 6 things happen, it's going to be about $8,555 of cost, right? Our total monthly cost or our planned value should be $8,555. That makes sense, right? Isn't there going to be a little bit of rounding error up and down on each one of these where it just kind of works out in the wash a little bit?
Yeah, I mean, definitely. I think that, any phase of project will have some kind of wiggle room one way or the other. You might spend
I
more time
agree.
in SD and then back and forth.
That's what I'm in complete agreement with you. So I think that's pretty good. Is there anything different happening in February than was happening in January according to this plan? When you look at that?
No, it looks to be the same.
Yep, to me it looks to be the same. So we've got another 8555 or projected cumulative goes up to 17,110. Does that make sense in there?
Yeah, that makes sense.
Okay, so here we've got a table, and that table can just be turned into a line graph fairly easy, right? In our table, we started in January and we go to December. Project starts at $0 and goes to 173,000. So you can see that we start in January, end in December, and we go from 0 to 173,000. We're just going back and forth from a table to a line graph. You with me on that?
Mm-hmm.
The interesting thing as I look at this, though, is at the end of June, I kind of go up and I say, wow, it's interesting. The end of June, this job only looks like it's about 35% done. It's going to take until what, the end of August for the job to be 50% done. How can that be that the time is halfway done with the job and we're not halfway done with the effort. Or it takes what in essence about 2/3 of the project schedule to the end of August to get halfway done with the work. Do you see the relationship there that I'm kind of pointing out, Aaron? Does that make any sense, or why would that make sense? That a project isn't halfway done with the work, halfway done through the timeline.